Uranus looks almost peaceful, a pale blue world drifting quietly between Saturn and Neptune. Saturn announces itself with golden rings. Neptune gives itself away through dark storms and supersonic winds. Uranus does neither. It just hides. From a distance, it looks calm. The closer we look, the stranger it gets. This is a planet that doesn't spin upright like the rest of the solar system. It rolls around the sun on its side, magnetic field tilted and shoved off center. Its seasons can trap entire regions in darkness for decades, and its atmosphere reaches some of the coldest temperatures ever measured on any planet. Uranus isn't boring. It's a mystery hiding in plain sight since William Herschel first spotted it in 1781. More than 2 centuries later, only one spacecraft has ever gotten close, Voyager 2, in January 1986. It photographed the moons and rings, took its measurements, and moved on toward Neptune. That one brief pass still shapes almost everything we know about this planet. The first thing it confirmed, Uranus is tilted about 98 degrees on its axis. Earth spins like a slightly leaning top. Uranus looks like someone knocked that top over and let it keep rolling around the sun anyway. The leading explanation is violence. Early in the solar system's history, Uranus may have collided with a massive protoplanet, possibly several times the mass of Earth. A glancing hit like that could have tipped the young planet onto its side and helped shape the strange family of moons still orbiting it today. Scientists still argue over the specifics, whether it was one impact or several, and exactly how the gravity played out. What's certain is the result. A year on Uranus lasts 84 Earth years, and because it lies almost sideways, its seasons are extreme. Around solstice, one pole faces the sun directly, while the opposite hemisphere sits in darkness for as long as 42 years straight. Roughly a human lifetime split between one long season of light and one of night. For decades, this dramatically tilted world looked almost dead. Voyager 2 saw a smooth blue-green ball with barely any visible weather. It took Hubble and later the James Webb Space Telescope to reveal a far more active planet underneath. Clouds, storms, seasonal shifts, polar haze, and rings that stand out clearly in infrared light. The quiet planet was never quiet. We just caught it during one unusual season, through one spacecraft. Calling it an ice giant is misleading too. It isn't a giant frozen snowball. Beneath the atmosphere sits a deep interior of water, ammonia, and methane, compressed under pressures and temperatures so extreme none of it behaves like ice or liquid on Earth. Some models even suggest carbon-rich compounds deep inside ice giants could get crushed apart under that pressure, freeing carbon that sinks slowly toward the core as diamond. Diamond rain sounds almost beautiful. The reality wouldn't be. There's no surface to stand on, just pressure climbing until ordinary matter stops behaving like anything familiar, laced with methane and hydrogen sulfide compounds that would end a human visitor long before the view ever got interesting. And underneath all of that, Uranus is simply cold. Its atmosphere can drop to around -224 degrees Celsius, the coldest planetary atmosphere we've measured anywhere in the solar system. For years, that came with a puzzle. Uranus appeared to release almost no internal heat, unlike every other giant planet. New analysis has complicated that story rather than solved it. The planet does seem to emit some heat from its interior, more than Voyager-era estimates suggested, but still far less than Neptune, its near twin. Nobody fully knows why. Maybe the same ancient collision that tipped the planet also changed how heat escapes from inside it. Maybe the interior is layered in a way that traps warmth deep below. Maybe Voyager just caught an incomplete picture during its one pass. The magnetic field only deepens the strangeness. Earth's field sits roughly centered on the planet. Uranus's is tilted hard and shoved off center, so as the planet rotates, that lopsided field drags a magnetosphere behind it unlike anything Earth produces. The planet isn't just sideways on the outside. The weirdness goes all the way through it. Even the rings are strange. Uranus has 13 known rings, but instead of Saturn's bright icy bands, most are dark, narrow, and nearly invisible. Beyond them orbits a family of moons, named mostly after Shakespeare and Alexander Pope characters: Titania, Oberon, Ariel, and Miranda, possibly the strangest moon anywhere in the solar system. Its surface looks stitched together from pieces that don't belong on the same object. Ancient cratered plains beside enormous grooves, ridges, and strange folded regions called coronae. One older theory held that Miranda had been shattered by a collision and pulled itself back together afterward. More recent work points to tidal heating instead, gravitational flexing from old orbital resonances driving intense geological activity from within. Either way, Miranda isn't the simple, frozen leftover its size would suggest. A small world with a genuinely violent past. That, more than anything, is why scientists want to go back. Several of Uranus's major moons may be more than frozen rock. Models and observations hint that some could hide liquid layers beneath their icy shells, possibly even today. Possible ocean worlds, orbiting a planet we've visited exactly once. That's the real frustration. We've had orbiters circling Mars for years, spent over a decade parked at Saturn, and studied Jupiter again and again. Uranus got one fast flyby. Voyager 2 still found new moons, new rings, and a magnetic environment strange enough that researchers are reanalyzing that 1986 data today. In 2024, one team argued Voyager may have arrived during unusually active space weather, meaning our whole picture of its magnetosphere could be based on one atypical day, one flyby, one moment out of an 84-year orbit. That's not nearly enough to understand a planet this strange. A dedicated Uranus orbiter and atmospheric probe has been named a top scientific priority. Years in orbit instead of hours in transit, with a probe eventually dropped into the atmosphere itself. Map the magnetic field, watch the seasons actually change, study the rings, fly past the moons, and look hard for any sign of oceans hiding under that ice. Ice giants appear to be common around other stars, yet in our own solar system, Uranus and Neptune remain the giant planets we understand least. Making sense of worlds across the galaxy may start with this pale blue mystery in our own backyard. Uranus was discovered in 1781. Voyager 2 visited in 1986. Nearly 4 decades later, nothing has gone back. It keeps rolling through the dark, rings barely visible, moons carrying scars we've only glimpsed, a magnetic field twisting through space, and an interior still hiding a story we still can't read. From far away, Uranus looks calm. That might be the most misleading thing about it. Sometimes the quietest worlds aren't empty at all. They're just the ones whose secrets we haven't reached yet.